Greetings and welcome to an introduction to educational research for educators. This is the first in a series of 3 research courses required for completion of your master's degree. In this course, you will be presented with a curriculum designed to facilitate your critical reading and analysis of educational research. Also, you will be exposed to the various types and functions of educational research. And finally, you'll have the opportunity to design and develop a research thesis or master's field project proposal. But all of this in good time. In this initial video, I would like us to take a look at the big overarching idea of scientific research, or what might be referred to as the scientific method. What is it? Why is it? Of what value is it? Now, for those of you who like definitions, get out your pencil and paper. Here comes a definition. Simply put, scientific research, or the scientific method, is a systematic means of inquiry that examines behaviors or phenomenon in our world using verifiable procedures, and whose procedures, methodologies, and findings are subject to peer review. Okay, the takeaway in that definition is that the scientific method relies on systematic observations to look at behaviors or phenomenon, and it uses verifiable procedures. And the procedures, the methodologies, and the findings are all subject to peer review by experts. Now, the role of science, the general role of science and the scientific method is to extend our knowledge of the universe by discovering, describing, predicting, and controlling the laws governing the universe. In other words, it's an attempt to uncover what is real or what is reality. Now, I don't mean to get weird here and go off on some philosophical trip down Alice's epistemological rabbit hole, but it is an interesting question. How do you know what actually is real or true? Especially in today's climate of fake news and sham investigations and lies. With that in mind, this video is intended to have 3 purposes. To have you explore what you accept and expect as reality. To have you take a look at how you reach that conclusion about what is reality or what is real, and to examine what your evidence threshold is. What level of evidence do you need to believe something is real? So just for fun, let's take a peek down that proverbial epistemological rabbit hole and see what we can find out. Imagine that the black area on your screen represents all knowledge, known and unknown, in the universe. Each time a researcher conducts a valid and reliable research study, they add to the knowledge about our universe. They partially fill in the void of what is known. As the process of scientific research continues, more and more of the void becomes known. Assume each square on your screen represents a piece of scientific research that adds to our knowledge base. Also, picture the different colors as representing different scientific disciplines, like psychology, astronomy, biology, physics, education, chemistry, etc. As science moves forward, more and more of the knowable universe becomes known and old antiquated knowledge and theories are cast aside. There is a progression from less understanding to more understanding. However, there is a caveat. There is and always will be areas of the universe that are unknown to us at any given point in time. The big picture is the grand function of scientific research. It methodically, step by step, attempts to discover the unknown and reveal new truths. That sounds like a Star Wars line for me. Anyway, let's leave the grand picture of science now and scientific research and take a look at the universe of educational research. The cartoon you see on your screen is a rather concise depiction of the main point of this video. Our weary traveler is on a treadmill trying to get to the truth, to what is real, and it appears he's on a fool's errand, going nowhere fast. Now, typically, there are some very basic ways we go about determining just what is real and what is not real in the world, and they are indicated by the arrows on the cartoon. One of the major ways we go about discovering reality is to rely on tradition, or our knowledge of what we have done in the past. Obviously, tradition is an important way of understanding what our world is like. Imagine if we metaphorically had to reinvent the wheel every time we encountered a new problem or situation. It is very useful to be able to rely on tested and trusted ways of solving problems or encountering situations, but there can be a downside on relying solely on tradition, as this brief video will point out.
A scientist placed 4 monkeys in a room with a stepladder upon which there was a bunch of bananas. Whenever a monkey went to climb the ladder, the other monkeys in the room were sprayed with cold water. After a while, each time a monkey went for the bananas, the others would attack it to prevent it from doing so. The monkeys learned to never climb the ladder. But then, one of the monkeys was removed, and a new monkey wearing a raincoat was introduced. Naturally, this monkey went for the bananas, and it was customarily attacked and prevented from doing so by the others. This new monkey learned not to climb the ladder. So when another monkey was substituted in and made the bananas, all the others attacked it, including the one in the raincoat, despite the fact that it had never been sprayed with cold water. A third monkey was substituted in, and then a fourth final monkey. And still, whenever a monkey tried to climb the ladder, the others would prevent it from doing so, even though none of them had ever been sprayed with the cold water. When asked why this was, one monkey said, "That's just the way it is."
As you can see, although tradition may be a very important way of interacting with and learning about reality, it may result in stagnation and loss of creativity and attacking new situations and problems with old, worn-out solutions whose time has come and gone. And as the video very poignantly points out, these monkeys were operating, the 4 of them at the end were operating, never having been sprayed with the water, yet they were carrying on tradition. So, although it is a valuable means of interacting with and understanding our world, tradition has its limitations. Another method of trying to understand our reality is the reliance on authorities or experts to guide us and enlighten us. But the problem once can be that one expert will say one thing and another expert may say exactly the other. Take global warming, for example, or currently now getting vaccinated or not getting vaccinated. So relying on experts and authorities can produce a lot of conflicting ideas about what is real and what is not real. Another way is the use of logic or common sense to uncover the truth. The problem with logic is that it's language-based. It's not based on observations of phenomenon or behavior in the real world. And the problem with common sense, obviously the cliche is, if it were so common, everyone would have it. Next, there's a broad category of interventions that might fit under the umbrella term of non-consensus realities that may be used to interpret realities. These might include such phenomena as seeing visions, hearing voices, altered states of consciousness, theories such as facilitative communication, alien abductions, and ESP. These are some examples. Oh, by the way, speaking of ESP, let me see if my ESP is working. Just bear with me here. I want you to think of a country that begins with the letter D. D as in David. Next, I'd like you to think of an animal whose name begins with the last letter of the country you selected that began with D. And then finally, I'd like you to select a color that begins with the last letter of the animal that you selected. Country that begins with D, then select an animal whose name begins with the last letter of the country that you selected, and then select an animal whose name begins with the last letter. Okay, if my ESP is working, it was Denmark, kangaroo, and orange. Anyway, back to the point. Non-consensus reality certainly can be considered ways of knowing what is real or not real, but they have great, great limitations. Faith is certainly another way of knowing and understanding the truth. The problem with faith is there are so many faiths. Which one is the one that we should have faith in? It becomes difficult to choose, and we wind down a rabbit hole. Finally, we have our perceptions, our senses. And they give us information on what reality is or what we perceive as real. This seems to be our best bet, so I'd like to spend some more time taking a look at perceptions. Our perceptions are based on the information our sense of touch, taste, smell, sight, and hearing sends to our brain. And actually, these are the traditional 5 senses, but we have many more senses than simply these. But that's more for your biology class or your psychology topic. But what happens is our brain receives the electrical signals from our sensory neurons. It directs them to the appropriate areas of the brain for processing, processes the information, and then turns the information into what we perceive as the world or reality. However, consider the fact that the brain is contained within our skulls. Our brain can neither see or hear or taste or touch or smell on its own. It is metaphorically deaf, blind, and dumb. It's walled off from what we refer to as the real world. The amazing thing the brain does is to take the incoming electrical information from our sense organs, processes the information, and then makes educated guesses as to what is real. That's right, the brain is inherently inferential. It makes educated guesses or inferences about the world. The brain makes these best scenario guesses about the state of the world around us based on the sensory input it receives. And it is those educated guesses that you and I perceive as being real, and not the sensory input itself. It's what the brain does with the sensory input, the inferences that the brain draws. What we experience as the real world is simply our brain's best guess as to what the world is really like. These inferences that the brain makes occur automatically, rapidly, and outside our conscious awareness. Let's take a look at an example. In front of you are two X's. So I'd like you to listen to these directions first and then follow along with them, but let me say them first. What I'd like you to do is this. I'd like you to place your left hand over your left eye, focus your gaze on the X on the left side, and while continuing to focus on the X on the left side, move your head slowly toward and away from the computer screen until the X on the right seems to disappear. By moving your head slowly forward and backward toward the computer screen, the X on the right side should disappear. Actually, it doesn't disappear. It's still there, but you just can't see it. You've probably encountered this effect in a biology or psychology class you once took. By the way, if you're having trouble making with the X, making it disappear on the right-hand side, put the video on pause and try a few more times, and then turn the video back on again. So the question is, where does the X go, right? The answer is that it doesn't go anywhere. It's still there. It's just that we cannot see it. And here's why. This is a graphic of your eye. And it has all of the different parts. And you can notice on the left side, you have the pupil and the lens and the iris. And light comes in and it's sent to the back to the retina. Now notice on the left side, you'll see the retina. And as you drop down, you'll see the optic disc where the optic nerve enters from the brain into the eye. And there's a blind spot there. We see images because they're reflected off of our retina, but there's a part of the retina where the optic nerve comes through the retina, and therefore it creates a blind spot. And so that's why we do not see the X when we move in a certain way, because what we have then is we have activated the blind spot. Now, let's try the process again. And this time, take a few seconds while continuing to focus on the X on the left side to notice the area where the X on the right side was. Okay, so cover your left eye, focus your right eye on the X on the left side, move your head slowly forward and backward until the X on the right side disappears. And what did you see? Well, you didn't see a black spot where the blind spot in the retina was, did you? What you saw was the gray color of the computer image. And how does this happen? Well, the brain, which by the way metaphorically hates ambiguous data, senses that the background of the screen is gray. So it fills in the blank spot with what it thinks is there, the color gray. It makes an educated guess. It makes an inference. Let's try this. I put a red grid over the X on the right side. Now, do the experiment again. Place your left hand over your left eye. Focus your glance on the X on the left, while continuing to focus on the, focus your glance on the X on the right, while you continue to focus No, my bad. Continue to focus on the X on the left side, and then move your head slowly forward and backward towards and away from the computer screen until the X on the right side disappears. If you did this properly, or if it was done properly, the X on the right side should disappear, but you should see the red grid. Again, if you had any difficulty, just shut off the video and try it again. What happens here is the brain infers that there was a red grid. So it filled in the blank spot with the red grid, even though the X disappeared. You should begin to get the idea that although the brain is an amazing organ, there's nothing like it actually in the known universe. It can, at times, give us misleading information about the nature of reality. One other thing, by the way. Let's take a look again at this image of the retina. It shows the blood vessels and veins coming in and out, but the entire retina is covered with capillaries, blood vessels, with blood having to go to the eye. So even though we see images very clearly, we never see any of the blood vessels or anything like that. Again, it's the brain making some inferences. Well, let's continue on here. Here's another very interesting example of the brain making educated guesses or inferences. On the screen, you should see a grid of blue crosses and 4 tiny dots. 3 of them yellow and 1 a light green. The one in the center is a sort of a lighter green. I'm going to play the video, and I want you to concentrate very hard on focusing on the light green dot in the middle. The grid with the blue crosses is going to rotate clockwise. Concentrate on that middle light green dot and observe what happens. Now, it'll take a few seconds before the rotation starts, so just hang in there. Now, concentrate on that green dot in the middle. If all went well, you should have noticed that while you were concentrating on the light green dot in the middle, the other dots, the yellow ones, tended to disappear or vanish, and then they would come back, but then they'd go away again. What do you think happened here? I'll give you a moment to sort of create a hypothesis as to why this happens. Well, the thinking is that the brain senses that the grid of blue crosses is rotating. And it reasons, or metaphorically it reasons, that if it is rotating, then it will pass in front of the yellow dots and block them out. It draws an inference. It makes a guess, and there you have it. Disappearing dots become the perceived incorrect inference that the brain passes on as reality. Take another look at that. Concentrate on that one in the middle. Very interesting. Here's another interesting example of the brain making educated guesses or inferences. This one deals with motion, specifically a motorcycle driving down a wooded lane. Take a look, and then we'll discuss it. Okay, so we get the idea that the motorcycle is sort of driving down the lane, although some people see it as coming backwards as opposed to going forwards. But there's movement. The brain takes in the sensory input and infers motion is taking place. The weird thing is that there really is no motion. You're not seeing a motorcycle driving down a wooded lane. You're seeing only 3 pictures, 2 of a motorcycle and 1 that is blank. This is what you're actually seeing. However, when these 3 images are shown in rapid succession, the brain infers that there's motion. Our perception of reality is that the motorcycle is driving down a wooded lane. The reality is quite different. There are just 3 photos shown in rapid succession. Again, the brain makes an educated guess. In this case, that the motorcycle is moving down the wooded lane. But the inference, again, is incorrect. Here's another example of our inferential brain at work. At the top of your screen, you'll see 6 images, 3 Pac-Man shape-like images, although they're orientated a little differently, and then 3 V's, which have different orientations. I'm going to relocate these. When the shapes are relocated, all of a sudden we see 2 triangles, and the innermost triangle looks brighter, a brighter shade of white. The reality is that there are no triangles at all, but our brain, again, metaphorically detesting incomplete data, infers that there are 2 triangles. Another interesting distortion of reality. Okay, what's going to follow now is a series of examples of our brain making faulty educational guesses or inferences based on sensory input that it's receiving. And I'm going to go through them quickly. You can always go back and look at them if you want. This one, if you'll take a look at point AB, there's a line AB and there's a line CD. Now, when we look at this, obviously AB is longer than CD, but the reality is that AB and CD are exactly the same. It's the context and perspective that they are presented in that induces the brain to some faulty inferences. On the screen here, you'll see an image of a square superimposed on a series of concentric circles. Or is it a square, really? If you look carefully at the vertical sides of the square or the top and bottom of the square, it appears in the middle, the sides seem to bend in a bit. So the obvious question here is, what's the reality? Is this a square or is it not a square? By the way, if you don't trust me, you can put the video on pause and just get a straight edge and put it up against to see that the edges are straight. This is an interesting visual demonstration of the concept of context surrounding information. When information is presented in certain contexts, when the brain receives it, it can influence the brain's interpretation of that information so that the brain infers something that really is not. Here's another example. These lines obviously do not look parallel, but they obviously are. Another example of how context shapes and possibly distorts our brain's interpretation of reality. Here's the same kind of a situation. They're exactly parallel, although the brain certainly does not interpret it as parallel. Here's another one. These 2 stars are put in the context of black lines and white lines. The blue color of both stars is exactly the same. However, the context that they are in makes it appear different, and so a faulty conclusion is drawn. This is one of the quintessential examples of how context shapes our brain's interpretation and processing of visual incoming information and distorts the perception. On the left side of the screen, we have 5 large circles surrounding a smaller circle in the middle. And on the right side of the screen, we have 5 small circles surrounded by a larger circle in the middle. But I'm sure you've guessed it. Both circles are exactly the same size. So another example of how context can interfere with the interpretation of what is real by the brain. So these 5 screens that we've just looked at should really bring home the idea that context affects our common visual sense. How what we think we see may not really be reality. Just think about how this may affect eyewitnesses that are notoriously irreliable. Let's take a look at some other common effects. Well, I'll let you read this. This is amazing. There are 34 words that appear on the screen. 11 of them, or 34%, are spelled correctly. 23 of them, or 66%, are misspelled. Yet you had no trouble reading the sentence. Again, the brain, not wanting to tolerate incomplete data, makes inferences on what is real and what is not real. Again, another example. The 2 bowling balls do not appear the same size, but in reality, they are the same size. Another example. It appears that the seesaw is tilted down to the left. Santa Claus is heavier than the elf. But the reality is that was just our expectation. The reality is they're exactly parallel, even though they do not look like it. Again, the brain draws a faulty inference. Now, this is an interesting one. What do you see here? If you are like most adults, you will see a naked man and woman in a romantic embrace. However, if you are around 6 years of age or younger, you see 10 dolphins. Take a close look. Young children don't have the sexual experience or schema or frame of reference that we do. So they see what their reality is, which are the dolphins. We see a man and woman in a sexual embrace. So developmental age is another issue that can affect our perception of reality. So all of this has brought us back to the essential question. What is real? And more importantly, how can we tell what is real? Are we left with a postmodern probabilistic interpretation of reality, or is there actual reality? And if so, how do we go about finding it? Well, epistemology, the word epistemology, is the branch of science that is concerned with the nature and scope of knowledge and has been referred to as a theory of knowledge. So epistemology is the branch of science concerned with how the researcher goes about determining reality. What is knowledge and how can it be acquired? What is the extent to which any subject or entity can be known? What is real and what is not real? And how do we know this? What is our evidence level? I want you to consider the diagram about science versus pseudoscience. Systematic observation about the world leads to beliefs and theories about reality. That's science. Systematic observations, collecting data, analyzing that data, and then developing theories and beliefs about reality from the observations. Pseudoscience, quite the opposite. One's beliefs or one's opinions about the world lead to beliefs and theories about reality. In this particular class, we're interested in science, not pseudoscience. Doesn't mean in your going about your everyday life, you don't have to pay any attention to the scientific method. But for the sake of this class, we are going to focus on that. Here are some assumptions of the scientific method. Now, as I've mentioned, most of the traditional sources of knowing, like tradition and logic and authorities, non-consensus reality, faith, common sense, our perceptions, tend at times to be unreliable. And then what is needed is a way of knowing that is reliable and valid. And again, the main premise of this course is that the most reliable and valid way to discover reality is through the scientific method. Again, it's the method consisting of systematic examination of behavior or phenomena, using verifiable data collection procedures, and having the results subjected to stringent peer review and replication. So the assumptions of the scientific method. The world is real, material, and knowable, that it can be measured. That's an assumption of the scientific method. Another assumption, events in the world have identifiable causes and effects. Another assumption, everyday experience and logical analysis are not enough for us to determine what is real and not real. And the final assumption, that scientific inquiry, systematic experimentation are the most reliable and valid ways of determining reality. Well, here is the assignment for this video. The directions: please respond in writing to the following prompts in the form of a Word document, no PDFs or Google Docs or Pages docs. Please put it in the form of Word because I deal with an ancient computer, which is about as ancient as I am. When you have completed your responses, create, this should be in R, a file titled Your Name. So you put your name, theory of knowledge, and email it to me at happyj1939@yahoo.com. So the prompts are, what was your overall reaction to the video? Second one, in your normal everyday living, how do you go about determining what's real? What is your evidence tolerance? On what basis do you decide what is real and what is not real? And then please add any other comments or insights that you might have concerning the video. Well, thank you very much for your time and for your work.